Section 9.4, we will continue to solve quadratic equations. This first example is going to show you how you can solve it using the zero product property. You don't necessarily need to know what the property is talking about because the gist of it is that you're going to set each of these expressions equal to 0 and solve for what t needs to be. So they have already factored this, so we're going to take 4t plus 1 and set it equal to 0, and we're going to do t minus 2 and set it equal to 0. Then we're just going to solve both of those equations separately. So on this left equation, we would need to subtract 1 first, so we get 4t equal to negative 1, and then we would need to divide by 4 on both sides, so then I would get t by itself and I would get it equal to negative 1/4. Now, I am okay with you writing it as a decimal. However, I don't know that IXL always wants it to write as a decimal, so you might need to leave it in its fraction form. And if that's the case, this is your fraction that you can put in right there. You will also need to solve the second equation. So for this one, all I need to do to get t by itself is just add 2 over, and then t is all done. So t would be equal to 2. So I would still have two answers like before, but they would be different numbers. So negative 1/4 and 2 would be my answers. Let's take a look at one more. So on this next one, I have x plus 1 and x minus 5. So they've already factored it, so I would go ahead and separate them into two equations. And then I would start solving. So I would subtract 1 from both sides on this first equation. So I would get x equals negative 1. And then I would add 5 to both sides, so then on this equation x would be equal to 5. So then my two answers would be negative 1 and positive 5. You're going to pause the video and try the last got it question. On this other one, you should be doing 2x plus 3 equal to 0 and x minus 4 equal to 0. On this left equation, you should be subtracting 3 from both sides, so you get 2x equals negative 3. Then you should be dividing it by 2. So negative 3 divided by 2 is negative 3/2. Then I would add 4 to both sides on the second equation, so x would be equal to 4. X would be by itself, so I would be done. So my two answers would be negative 3/2 and 4. Again, I'm okay with you changing this to a decimal as long as you don't round it. So if you got negative 1.5, that would be fine. But again, you'll want to check your IXL to make sure that they would like those as decimals. Alright, now the other part of this lesson is what do we do when it's not factored? So if you don't have the set of parentheses in there to start with, you have to factor it. So let's go back to how we factored it. Remember our first step was that we slid that number over and we multiplied. So this is going to stay as 15 since there's an imaginary 1. Then we did our x and we put 15 at the top and the middle number went down at the bottom. Then we found all the factors of the top number, so all the factors of 15, and we find which pair will add or subtract to the bottom. So we would use 3 and 5 so that it will add up to 8. Then what we did is we rewrote this expression with our new numbers. So x squared stayed the same, 8x became 3x and 5x, and then 15 stayed the same. After we have rewritten it, we factored out a GCF by grouping the first two and the last two together. So on the first two we grouped together, we can take out an x from both of them. When I divided this by x, I got 1x left over. When I divided this by x, I got 3 left over. On the second grouping, I could divide them both by 5. So I pulled out my 5 and what was left was just x and 3. Remember that when you're doing this, the stuff that's in parentheses has to match in order for you to continue. It does match, so then I can write my two sets of parentheses. The x plus 3's come out, and then I write my other two GCFs together, so I have x plus 5. Now, at this point is where you were at from the beginning problems. So now is where you would need to separate them into two equations. So x plus 3 equals 0 and x plus 5 equals 0. And then solve them. So I would subtract 3 and get negative 3. I would subtract 5 and get negative 5. So my two answers would be negative 3 and negative 5. Let's look through another one of those examples. Okay, so on this next one, we again have to slide over, have to slide over that first number. So when I slide it over, I get negative 20, and then my middle term gives me my bottom number. Then I find all the factors of 20 and find which set will add or subtract to 1. So that's why I'm using 4 and 5. I need them to add a positive 1, but then multiply to a negative. So we want the smaller number to be negative, which is why 4 is negative. I then rewrite my expression so it becomes p squared, negative 4p plus 5p, and drop down my negative 20. I group the first two and the last two together and find the GCF. So the first two I would pull out a p, which when I divide them both by p, I get p minus 4. And then on the second set, I divide them both by 5, so I would get p minus 4 as well. Then I can see that I have the same stuff in the parentheses, so I would have p minus 4 come out. These two pieces that are together will go here, so that's why it becomes p plus 5. I rewrite it as they're two separate equations, and then I start solving. So I would subtract 5 from this left equation, so I would get p equals negative 5. I would add 4 to the second equation, so I get p equals 4, and so my two answers would be negative 5 and 4. Okay, I'd like for you to pause the video and see if you can do the last question. Alright, so in the last question for this got it, you need to slide the 2 over. So when I multiply, I get 36 on top. My middle term has negative 15. So my bottom number is negative 15. So I'm finding factors of 36 that will add or subtract to 15. So I'm using 3 and 12. Since my top one is positive and my bottom is negative, that means both of these need to be negative. So now I'm splitting up this negative 15a and rewriting my expression. So I have 2a squared minus 3a minus 12a plus 18. I group the first two and the last two, and I find my GCF. So I take out an a, and when I divide both of these by a, I get 2a and then negative 3. The second one I'm going to need to divide by negative 6. So remember, if that first term is negative, it goes with it. So I'm going to divide them both by negative 6. So I get positive 2a and negative 3. Now I can rewrite my factors. So 2a minus 3 comes together, and then my a minus 6 goes together for the other one. I split them into separate equations. So a minus 6 equals 0, and 2a minus 3 equals 0. So now I'm going to add 6 to both sides, so I get 6. This one I'm going to have to add 3, so I get 2a equals 3. I still need to get rid of the 2, so I'm going to come back and divide by 2, and that's how I get 3 halves. So you should have 6 and 3 halves, or 6 and 1 1/2 for your answers. Now, since you're going to be doing IXL, you will have some other type problems that involve the GCF. So for example, if you have a problem like this one, where you have the set of parentheses, anytime they have the parentheses, they've already factored it. So you get to automatically just set them equal to 0 and start solving. So I would put 3x equals 0, x minus 5 equals 0, and then I would need to solve. So I would divide both sides by 3, which leaves me with x equals 0. And then on this one, I would have to add 5 to both sides, so I get x equals 5. So it's still the same thing as before, but I just wanted you to see that this first part is what you want to set equal to 0. Now, if they only give you 2 terms, you still want to group these two and find the GCF. So I can divide both of these by 4. I can also take off 1x from both of them. So my GCF is 4x, so I would take that out. When I divide by 4x, I'm left with 1x. When I divide by 4x, I'm just left with 5. Again, this is now factored, so we have to separate it into 2 equations. So 4x gets equal to 0, x plus 5, it gets equal to 0. So I would divide by 4, so one of my answers would be 0, and I would subtract by 5, so one of my answers would be negative 5. So I know this is kind of a long lesson, but I did need to be thorough in trying to remind you on how we factored all of those types of problems. So if there's 2 terms, you're going to focus on doing the GCF. If there's 3 terms, you have to do that full process where you slide it over and then split it up into your 2 forms so that you can find the GCFs.